So today the plan is to just to cover a short thing that I forgot to mention. Well, I actually mentioned it, but I want to just to emphasize it about NPV calculations. Then I want to give just a quick overview through Excel. I know how many of you use Excel quite actively before? Okay, most of you. So we are going to have that should be short, and then we are going to solve one of the in problem 3 in exercise set 1, where we'll try to solve it here in class. Okay, the one of the tasks. The way, I have tried different ways in the past to make it. So one way is that I leave you to do it with some indication from me, but that usually takes a lot of time, and some of you do it very quickly, some of you do it a bit slower, so that creates some conflict. Some people get bored and some people get stressed. So the option that has worked the best in the past is that I do it step by step here, and you follow me, and if for any reason there is something that is not clear, we stop and we have a discussion. Okay, but I will try to do it step by step, and you follow it on your computers. Okay, and then yeah, so that's what we are going to do today. So just yeah, let me comment on that later. That's a nice. This is in the supplementary material that I uploaded on Blackboard, and that actually came from the article by Halvorsen, and it's like showing what all the things that come into account on the estimation of NPV, okay, per year. Yeah, and it's very intuitive, very pictorial. Like you see, for capex, you have here in capex he's including also the Drillex. Okay, so that's why he doesn't keep a separate name for that. But you have the wells, the main cost of the wells, the facilities, and you have the offshore structure, okay, which are like the main costs. You also have some other things, like I mentioned in the exercise. You have the umbilicals, you have the subsea templates, you have the subsea systems, you have many other things, but to make it simple. Then you have yeah, and here having also like a small caricature saying that the investment actually you have less and less until project startup, and these are OPEX, which he says operation and maintenance cost. That also, depending on the output, should also expect it to go a bit down with time, with production. The oil price, we're very uncertain. Is it going to increase during the life of the field, going to go down, or remain flat? And to calculate the revenue, you need the price, and you need the oil profile, and like I told you, right, there are different ways to produce it. High plateau, very short; long plateau, that takes longer time. And then there is a big uncertainty on usually what will be the gas, how much gas I'm going to get with my oil production, and how much water I'm going to get, and when. And also the message that I mentioned yesterday is that you need to have some level of detail to calculate NPV. Okay, first you have to know for the drilling how many wells you need. For the production profile, predicting the production profile, you need probably to have a very rough reservoir model. Okay, so you need to have a reservoir team in place, and with enough information to populate that model. Then for the facilities, what kind of separators you need, how many pumps you need, the control unit. So for that you also need a dedicated team, and you also need enough input. For the offshore structure, you also need people looking at the marine environment, yeah, how much weight you're going to have, how will be the logistics of the marine operations. Okay. Also maintenance and operation, how many people you're going to need. So you already need, that's, not in the early phase, DG0, DG1, but after you have selected a concept and after you have going more in depth to the concept and start to define all the different things that that concept has. Okay, so keep that in mind. You need some level of detail, and at this point, when you're estimating NPV, you usually have at least a small team, but you have a team of people, technical people working on each area. Okay, so that was the short comment I want to make on that. And yeah, so let's go to the exercise we are going to solve today. It's on my website. It's exercise 3 of problem 3 of exercise set 1. But first I want to open this document very quickly. Okay, and these are recommendations that I think you should you should follow as much as possible. Okay, so first attach any file that you used to solve the problem, because sometimes you just attach the summary. And then if I want to see if you have any mistake, okay, in your calculations, the numbers don't seem right, I don't have any way to verify that number, where that number came from. Okay, maybe you made just a dumb mistake, okay, and just maybe change the units, or maybe you were putting an extra 0, and that really makes the number at the end to look bad. But maybe you have done all the procedure correct. You understand properly the procedure. So in order to have a better evaluation of your exercise, I suggest you deliver everything you use. Okay, your Excel files. Later we will use HiSys. All of the files that you use, you attach it to your delivery. Okay, we are going to discuss today, and we have something called Excel etiquette, which are like guidelines or for to how to properly make an Excel sheet. And I'm going to explain some of them today. But basically, the main intention is that the sheets should be readable by some other person. Okay, if you give it to me, you give it to a person some other place in the world, they should understand, everything, at least what the Excel sheet is making, and also it can be usable. It's not like there are some hidden things that only you know how to operate. Okay, if they say, well, if I change this number here, then I should be able to see what happens with the result. Okay, so that's the main intention, and it sometimes can be challenging to make it, but you will learn, hopefully with time during this course, you will learn how to make it. So you can very well include text if you want to clarify something, some order, some sequence in which you made the calculation, some assumption you made for your problem, some formula which is not very clear. You also can add sketches to Excel if you feel like that, where in which point I'm making the calculation, for example. Everything that you need to clarify the Excel sheet. Especially important, the plots. We are going to talk slightly about plots, but should have a readable and proper size. I recommend more than 16 points font size. The title should be in bold. Okay, and you have to say very clearly the variable name, the symbol, and the units. For example, you can say reservoir pressure, okay, comma, the symbol that you're using for reservoir pressure, and then at the end the units of that variable. The three things should be in each axis. And this is optional. It has been, the third point has been a kind of a controversial thing during the past. Okay, sometimes, and that's completely up to you, it's easier for me to correct if you make a summary document. Okay, you put all the results very simplified. You put the plots, some very small short comment on the plot, and put maybe your observations in a short document. The so that's optional. You decide if you want to make it or not. If you feel like the Excel sheet is too messy, okay, that I will have difficulties correcting, I suggest you make that document. Just a summary addressing the tasks that were done and very briefly, the results and your conclusions on that. But only if you wish. If the Excel sheet is self-explanatory, you feel like, you had everything to understand it properly, you just deliver the Excel sheet. Okay? It's not going to give you any extra points, less points. It's just if you feel like you have to do it to make it more understandable. And also, I'm not expecting a big report with index and theoretical. Some people have done that in the past, and it's very nice. Okay, theoretical background, etc. But it's up to you what you want to deliver. When you make, if you're going to make that document or any other Word document, when you convert it to PDF, there are some settings. If you go to printer settings, be sure that the resolution is high enough. Okay, they have some settings like standard, high quality, high resolution, something like that. So be sure that you test several of these options and see which one, because sometimes the figure, it looks very nice on the Word document. When you print it to PDF, it starts getting very blurry. Okay, the lines, and then it's difficult to read. So make sure that doesn't happen, and that you do by changing the resolution of the printer. Okay, be careful with that. Okay, so let's go to exercise 1. And we have to download problem 3. Okay, so we are going to download also this Excel sheet. Okay, and we are going to again focus on this Goliath field that is a bit controversial, has had a lot of problems in the last month. Some to do with the electrical system. They have had some issues with that field. Okay, but now let's say we are again on the early phase, and we want to find, as part of the PDO, we already made our NPV calculations, or that's what you are going to make. But another step is to estimate the original oil in place and the total recoverable reserves. Okay. And it has two formations, has two main reservoir units. One of them is Kobe and the other is Real Grunen. But we are going to look just on one of these pockets. If in a given reservoir, like you will see in the Hebron field, if you have 5, they call it pools, okay, then you have to make that analysis for each one of the 5 containers. Okay, in our case, we are going to look at one just to make it simple. So your first task, you have to perform a probabilistic estimation of the TRR and the original oil in place of the Kobe reservoir, and the subsurface group, in this case that they are very strongly on the geologist and petrophysicist. They have given all the factors that you need to calculate, the hydrocarbon pore volume, net to gross, oil saturation, and the formation volume factor. Okay, we're going to use the same equation we were using, I showed you yesterday. And it's saying that the recovery factor, it's all of them, all the others are uniform. Okay, all of the, so let's make that information. I'm going to copy that paragraph. Okay, so now we are solving. I'm not going to solve all of it, but just one part of the exercise. So that will be exercise 3 or problem 3 of exercise set 1. And we have the formula. If you can help me if I make any mistake. So NPU was Brock volume, porosity, oil saturation, net to gross. I'm going to use it like that. The recovery factor and the BO, right? This gives me the pore volume, this gives me the oil volume, then this gives me actually what the hydrocarbon bearing layer. So this gives me the total oil I have, but it's in local volumes, okay, in local subsurface volumes. Then I divide by BO to get standard conditions volumes, and that's everything I have in place. Okay, but if I actually cannot recover all of it, only a fraction of that, and for that I use this recovery factor, which is a very uncertain parameter. And N, it's also asked of me to provide it, and it's actually just the same, but without the recovery factor, right? Okay, so let's say this one will be a uniform distribution. So you get the idea already that you need just a minimum and max, okay? And hydrocarbon pore volume, so that's this guy here. Net to gross is also going to be uniform, oil saturation, and the formation volume factor. Okay, so all of them are going to be uniform. So for that I need just minimum and maximum. Now let's see what happens with porosity and with the recovery factor. The ultimate recovery factor is presented by a triangle distribution. Okay, so I'm given the 3 numbers I need: minimum, maximum, and the mode. Okay, so if you remember the triangle distribution, so for the FRU is going to look something like that: 0.18, 0.25, 0.35, and 0.25. Okay. Now on the porosity, and that's something that sometimes happened, you have, because maybe there was not enough information, they're using different models, they're using different interpretations of the same data. You have, and that's a problem with having too many experts. Okay, you have an expert A, which is saying you should use for the porosity just a uniform distribution because it's very uncertain, and use 0.18% and 30% porosity. That's the expert 1, the expert A. While the expert B, he says, well, I'm a bit more clever, I know how to interpret better the data, and he says, well, no, actually it's better if you use, it's more accurate if you use, I can, that's porosity, okay. And he says, well, actually I can find exactly that will be more likely that you have 0.18, 0.30, and here will be 0.25. Okay, and that sometimes can happen depending if you have different schools, if you have different ways to interpret the data, you don't have enough data, then the expertise and the way to interpret the data can give you different. So what we are going to solve here in class, we are going to solve. So you're asked to get the calculate. That's the main task. Calculate TRR, calculate N, both distributions, for expert A and expert B, and compare. That's your main task. So in class we are going to solve we are going to solve just n, right? And we are going to solve for expert A, because I want to leave the difficult part for you. That's how life works. Sorry. Okay. So let's open the Excel sheet. Those of you who want to follow, just go ahead and open it. Okay, so that's what you should get, and you have two. So let me take a copy of that. We are going to use just what the petrophysicist A said. So let's take. I'm going to take a screenshot of that. Okay. So what I suggest is that we do is exactly what what we said last class. You're going to create here below one row that will have the variable name and the units. Porosity, that is just a fraction. Net to gross, it's also a fraction. Saturation of oil, which is just a fraction, and the BO, which it's also non-dimensional, but we like to use barrels per standard barrel, just to emphasize what is the meaning of BO, right? So that will be, like I mentioned last class, that will be the input. And here you have just one cell, which is the output, and that will be N, right? And then the units of N are in? Okay, standard barrels. Yep. So all of them are going to be input, and here we'll have output. Okay, so let's discuss some things about Excel very quickly. So Excel setup. Okay, so first I want you to go to, first we have to lower the macro security. A macro is the way Excel has a module called a VBA, okay, that is called Visual Basic for Applications. And by default is deactivated, because anyone potentially can go and they send you some prints from, I'm not sure if you have received this email, prints from Nigeria offering you money. Look at this Excel sheet. And then inside they can have a code that can do something, can steal information, can send a file to some other computer. So by default is deactivated. But like you are the only ones that will be using it, right? And you won't be opening any file from any prints from Nigeria in the future. So I say just lower it such that you don't get any problem running, for the things that we do in our course. So you go to File, go Options, Trust Center. Okay, Trust Center Settings. And Macro Settings. Okay, it's a long way. Let's make it again. File, Options, then Trust Center. It might look a bit different depending which version of Excel you have. Trust Center Settings. Okay, and you go up in the left menu to Macro Settings, and there you have four settings. So you're going to choose the last one, enable all macros, and it's giving you the warning. Okay, if the Nigerian print sends you an Excel file, you're going to be screwed. So be careful, because this all the other options is, you know, that you have to actually click OK. You have to accept that you run macros, and sometimes you forget, you don't click it, and then you have problems because your code doesn't run. So I suggest just choosing that option from the beginning. Okay, so that was in File, Options. Then you have Trust Center, then Trust Center Settings, and then in the left menu, on the left menu, you have to click on Macro Settings. Okay, you get this screen, and you have to select, not sure why the pictures come so big, but you have to select the last option. Okay, so such that you won't have any problem. You don't have to remember to click OK, to accept. If you can do it, that's fine. You can use one of the other options like this one, but if not, I suggest you use that option. Okay, then let's see what else we have. There is something else we have to make. By default, usually Excel, anytime you put, for example, I put okay, so you have to click OK here to accept the changes. By default, if I put, for example, I have put two numbers, right, 2 and 3, and then this one will be just the product of 2 and 3. If I change here, I put to 4, it's going to change automatically. Everything is dynamically calculated. That's the default behavior of Excel. But for some reason, maybe your Excel sheet is too big, is costing too much to the PC, you know, it's causing it to use too much processor, it deactivates that automatic calculation, such that you have to do it manually. Okay? And that you do, if that ever happens to you, you have to press F9 to force everything in the Excel sheet to be calculated. But to avoid that behavior, you have to go to Options, again, File, Options, Formulas. Okay, and here you have an option called Workbook Calculation, and it has to be set to automatic. Automatically, if you make any change on the workbook, everything else should be recalculated again. If you put manual, then every time you make a change, you yourself have to press F9 to execute all the calculations. Okay, so I suggest you use, and that sometimes, if it's a very Monte Carlo simulation, very time-consuming process, the computer automatically is very smart and saying, I'm going to disconnect this automatic calculation. Okay, so it's File, Options, Formulas. So let's put that here. Okay, and it should be on that option. And if by any reason you suspect that it's having the manual calculation, to execute all calculations on an Excel sheet, press F9. Okay. Press F9 and everything will be calculated. Okay, then another thing you want to make, we are not going to use it too much in this course, but another thing you want to make, it's yeah, this enable iterative calculation, okay, on the right, and just leave the default options. Okay, I didn't have it selected, so and that also is called sometimes circular references. And there is an exercise where we use that, but it can be also solved without it. So, okay, so that's this mark here. Okay. Okay, then you have to. There are two main things that we used. We use something called solver, okay, in Excel. So we have to enable the solver. How many of you had used the solver before? Quite, okay, not too many. So the solver, we will see we are going to use it very actively, but it's like a special wizard we have in Excel that if you want to drive a cell to a particular number, it allows you to do that. To find, it's like a root solver, okay, it's like a root finding, a very sophisticated root finding tool. And the other thing we want to enable, it's the analysis toolpack. Okay, to do that, you go again to File, Options, Add-ins, here in the left menu. Okay, and then you go click here at the bottom, Go. Okay, and these two, they should be checked out. So that was in File, Options, Add-ins, and then you press Go, and then you obtain that, and these two should be marked. And after you press OK, you should check that in the data, you see here all the tabs you have. In the data tab, you should have these two activated, data analysis and solver. These two buttons should be available. And maybe remember, sometimes it gets deactivated by some issues, so you have to reactivate. Be sure that that's active. If you have something that requires a solver, okay, so that's the general setup of Excel. There are some other things that we are going to talk a bit about Excel, what I mentioned before, etiquette. Etiquette, I think is with one T only. Okay, the manners that we have to use to work with Excel. So first, identify your sheet. The first thing I want to see when I open your sheet, or that you want to see also, is that exactly what we have here at the top, okay, but not exactly like that. I'm not following my own. Okay, so first we are going to say we want my name, the name of the person. Then we want to put the date, and the format I like to use, and I hope also you follow, it's first the year, then the month, and then the day. And then you put a description, what is the file doing. So in that case will be exercise 1, problem 3 of our course. Okay, but that should be the first line, such that I know who is the owner. If it's a group, you have to write the 4 names or 3 names. So name, that will be date, and date we use year, month, and day, and that's the title or the description of what title. Then the second thing is to use color code for the cells. And the color code is, if it's a user-defined input, is something that you can change later. For example, I gave you here in this file the porosity. You see they are red because that's something that someone, the petrophysicist, told me that number is from here to here. What do you think is going to happen in the future if you are working in this project? Probably they are going to come back and say, sorry, it was not 0.18, it was 0.12. And you, in that case, if you did it properly, you're not going to sit and cry because you have to do all your calculations again. You just come here and retype the number. Here you have the results. Okay, that's the intention, that you just change that number here, and then everything else will automatically change. Okay, that at least is our goal. That you don't sit and cry because you have to dedicate again 2 days to make your calculations. Okay, so red we use for user-defined input. Okay, or things that will change, or that potentially might change, that might potentially change. We use blue for the results, okay, things that are a product of a calculation. And the last color I use, it's violet, that you use for constants. Okay, the gas constant, the gravitational acceleration, things that they are not supposed to change, and we are not going to use many of those here. Okay, what happens if we have a very long, that's okay if we have for example input, so a few for few input output, follow okay, the convention given below above. Now, like in our case, we're going to perform a bunch of simulations, and it will be too many colors. Okay, so for long rows, okay, let's say you are going to have 1,000, then just use black. Okay, and that's what we are going to use here. Okay, another thing, so that will be number 3. It's figures and plots go in a separate sheet. Okay, when you make the plot, don't leave it hanging, in the main area. but just put it in its separate sheet. So it will appear here at the bottom, and then you have to make the proper name. Okay, plot of reservoir pressure, for example, versus time. Okay, like I mentioned before, so the axis titles. So remember, you have variable name, variable symbol, and units. Okay, and okay, usually what I like to use the font size. It depends a bit on the resolution of your computer, but the font size is something between 16 and 18 points. Some people have to use 14, but I think most of you, most of the people use 16. Okay, make sure that the points should be visible. Okay, in your plot, all the data points, and you should be join them with a curve. So the type of plot we use is scatter plot with line. Scatter point with line. Or we also might use, especially for this exercise, we're going to use the bar plot. And if you have, for example, you want to plot two variables, let's say this one is reservoir pressure, okay, that will be, I don't know, from 600 bar down to maybe 100, okay, but you have another variable which is the rate, and that, let's say this is time, okay, T in days, and this is reservoir pressure, TR in bar, okay. If you have, for example, the rate goes from 100,000 barrels per day to, I don't know, 20,000, you see that the two scales are very different, but you want to show something. For example, that at the end of plateau, you find some reservoir pressure, something happens with reservoir pressure. Okay, so for that, I recommend plotting it in the secondary axis. So you use the option plot series, and we will, you know, in secondary axis, such that you can still show maybe the production will do something like that, and this series will be plotted with that axis, and this series will be plotted with that axis. And still you can show the two variables which have different orders of magnitude in the same plot, if you feel that that's something you want to do. So let's take a break, 15 minutes, and we come back to actually solve the exercise. There are some more things I want to, but I think it's better if we start with the exercise, and some of these things will pop up. Okay, so first I say, on this Excel sheet that you got, let's say put here the number of iterations, okay, which iteration that will be, right? And here we said we want to make 1,000. So one way to do it, which is a bit time consuming, you can use 1, 2, and then Excel is smart. You select both of them, you go to the bottom right corner until you get the cross shown, you click with the left click of the mouse, and then you drag it. You see, and it continues the same sequence, increasing one by one. Yeah, and you can do that, just drag it all the way until you get 1,000. Until you get 1,000 iterations. which is not the best, the smartest way, but it works. Okay. Another option is that you use something called fill. Okay, and you want to fill a series. Okay, you want to fill it in a column. Okay, so first I have to click on the first. Let's say I didn't do it like that, but I want to do it, in a bit smarter way. So I will say I put the first, the starting point. Here you have to connect your.
Oh, okay.
Where the first number is going to be. Okay, so you go to fill series, and you want to fill the whole column. Okay, and you want to go by 1 and stop at 1000. Okay, and then you click OK, and it didn't work. Is it linear? Is in rows. Yeah, for any of you, did it work? No? Series, rows, I think it's in column. 1000. Oh, I think you have to put, you have to put the number, and then you have to say like that, and I want to fill the whole column. Okay, you have to put the first number.
Automat or which?
Linear. Okay, so you have to use linear. You have to put the stop value 1000 and in the column. Okay, you want to fill only one column. Okay, that for 1000 you can just drag it yourself. Like I mentioned, you take two that they have already the pattern, and you start dragging it by the bottom. Okay, with the cross. But if it's 8000, might be a tiresome process. If it's 1 million, then you never finish. Okay, so remember this trick with fill. So we're going to put it here on the document. Okay, fill, and that is located in home. Take a screenshot of that. And that can work for even a row, or can work for so that is fill a column automatically. And you have to use the series option. Okay, the good thing about that, because now I have a column that goes from 1 to 1000. If I put something next to it, for example a number 1, okay, and then I want to drag it to put next to each point number 1, I just go again until I get a cross. Okay, I double click, and it should spread all the way to the last row. Okay, so that's a useful thing. If you ever need to, for example, a formula you want to apply through a very long column, then you just create this one first, and next to it you can drag all the others. Okay, that's not what we are going to do here. So number of iterations, that doesn't have any unit. So let's go now to, so I can copy just these headers from here. And the volume factor. Yeah, those are all the things that we need, right? And then we put here 1, which will be n. That's at the end what I'm going to calculate, and that will be in standard barrels, or I can even use it in million, but let's keep it like that. Okay, so you say we have to use our conclusion, the number we have to put in each iteration is random, right? Completely from the top of my head. So I have to choose a number between 18% and 30%, any number. To make that automatically, there is first there is a procedure. So the random sampling is usually made using the what we call the cumulative distribution not the PDF. Okay, if you remember, PDF stands for probability distribution function. Okay, so if we go and look at the uniform, for example, let's look at the porosity, right? You had a minimum porosity, you had a maximum porosity, and you're saying that it's uniform. The probability of occurrence of each one of them will be the same, right? So that's a probability, we call it PDF. But I can calculate based on that the integral, okay? The probability of having a porosity value equal than that or less. Yes? So if I do that, if I integrate a constant number, what do I get? You just get a slope, right? Yeah, just you get a line. Okay? And here, that's what I call the cumulative probability, okay, or the cumulative distribution. So that means I have 0% probability that the porosity will be equal to the mean or lower, right? But as it increases, I have, so this is a number that goes between 0 and 1. So I have, for example, here will be 0.5. I have 50% chance that I will have a porosity which is equal to that one or lower. Okay, and that I do by integrating this. But so why I go to this complicated, and we will see that's actually what we use. The distribution we use for the N and the TR are actually, even though I calculate it and it looks like that, I'm interested in knowing that number. Okay, because I want to know how many, that at least I have those reserves or more. Okay, that's the way that it was constructed by the industry, that I want to know at least to be sure that I have that number or more than that, okay, or less than that. I'm not interested exactly in knowing for this how much, what is the probability of that for one particular reserve. I want to know in this cumulative way. But that also makes it, fundamentally makes it very nice to make the sampling, okay, this random sampling. If we have a random number generator between 0 and 1, okay, so we can take a sample in the cumulative distribution and from there convert it to a number. Okay, and then doesn't matter, I don't have to make a random generator for here the numbers will be different, right here also the numbers will be different, and the minimum and maximum, they will have different scales. But if I use the cumulative distribution, then all of them end up in the same. All of them, if I integrate them, all of them should be between 0 and 1. So I can have just one generator of random numbers between 0 and 1, but then I translate to the actual number by using the CP. Okay, and that's the way it is done. I make the random number sampling, I make it on the CP, and then from there I translate to the variable. Okay, and in this case it's very simple. It's just, you know, I would say a straight line, but when the distribution becomes more complicated, this also becomes kind of more complicated, the curve. Okay, so you're not going to work too much with more complicated functions, only this one and triangle, but that's the main challenge, that just the equation becomes uglier and uglier. Okay, so how do we describe? Remember, we don't want to make it visually. Okay, it will take you know, forever. We have to make 1,000 iterations. So what will be the equation we have to use for that case? Okay, just the equation of a straight line, right? So what is the equation of the straight line here? So we say that the y, okay, so 1 minus 0 divided by phi max minus phi min should be equal to a value phi star minus phi min minus 0, and here I have the cumulative probability that I need, right? Just like that. And then I clear this CP, and at the end I end up with the CP of, I'm going to call it not porosity only, but it might be for any variable. Okay, we're going to use it for any variable. So here I will say that's the name of the variable, max, and that's the name of the variable, any variable, min. Okay, so CP has a function of yeah, we want to make it actually the opposite, right? We're going to give this number, that will be a random number between 0 and 1, and we want to calculate this porosity star, right? So we say this x will be equal to x min plus x max minus x min multiplied times the CP. Okay, yes, and then that CP is a random number I'm going to use between 0 and 1. Okay, and in that way I don't have to make anything customized for porosity, for rock volume, for saturation. I can just use one expression and then I use the same random number generator. Okay, by sampling on the cumulative distribution. So let's make that expression, and we just need now a random number generator that we have available in Excel. Okay, so let's try to do that. So this one will be, let's make it to a side to see what expression we have. So we say to apply a formula, we say equal to the minimum, okay, let's say this is the rock volume, so we will use that number, okay, plus the maximum minus the minimum times this random number. Okay, and Excel has a random number generator that is called rand. Okay, and here it gives you a description. It returns a random number greater than or equal to 0 and less than 1, evenly distributed. So that's exactly what we need, a random number generator. Okay, so I open and close, and here I want to make, just before I click enter, a few things depending on the Excel, the language of the Excel that you have. Some people have it in Spanish, some in Russian. So the name of that random number generator will change. Okay, I think in origin is tilfeldi. Yeah, in Spanish maybe it's the same rand. In Russian I don't know how it is, but that number will change. Okay, that depends on the language of your Office package. Okay, so be careful, you have to find the equivalent. And now there is another thing. If I leave it like that, so let's make just the experiment. Okay, I click enter, right? And that gave me a completely random number, but it should be between these two. Okay, but now I want to do exactly the same, to go on the cross and then drag it down. But here, just know that there is something fundamentally wrong. Now the number went outside the bound. And if you click, you see, if you click here at the top, it shows you the equation. Okay, and if you click there, it will show you what variables it is using. Okay, what input it is using. So you see, it changed. When I drag it down, actually it's changing the position of this input. So to keep it frozen, I want to keep it frozen. And you see that number now changed. Now it's much more closer to 6.25. So I have to freeze these two. Okay, I have to freeze this number so they will be always in the same position. Okay, to freeze it that it will not change, you have to press F4. Okay, when standing on the cell tag. So you click on here between B and 6, and then you press F4, and you see $2 signs appear in front of the letter and in front of the number. Okay, so that means it's blocking it, so such that when I drag it down, it won't move. It always keep on the same place. Now I ask you, is that wise to make it? Or not?
Not now.
Not now? What would be kind of a smarter idea? You see, it will be the same formula, right? For all parameters. So if I want that if I drag it to the right, it will change, right? With the input it has on top. But I don't want to change when I drag it down. So how do I achieve that? Any suggestions?
To put the dollar only in the number.
Okay, you put the dollar only in what you don't want to change. Okay, B gives you the column, so you want the column to change from B to C to D, but you don't want the number to change from 5 to 6 to 7. Okay, so I'm going to put the dollar, and to make it, I can either erase it manually, so I can just do like that, and now it will change. If I drag it to the right, it will change from B to C to D. Or another way is that I press F4 once more. Okay, so if I press F4 once more, it goes through all the different options. Okay, so it should look like that, just dollar in front of the row number, and then I click here, get the cross, and drag it to the right. Okay, and here maybe this BO, I can use a different format. So I go there to number, and I want to put it general with 2 decimal places. SO can stay like that, this one also. Okay. Okay, and it seems that they are within the range that I wanted. Okay, now I come to the basic, I have generated random numbers for each one of my input parameters, and then I calculate n, and n is nothing more than this one, right, times this one, times this one, times this one, divided by the BO. Okay. And you see the numbers change. Every time I click something on the sheet, if I click here again, enter, the numbers change. The random is always, when you recalculate everything on the sheet, the random is always changing. But that doesn't matter. Remember, Monte Carlo doesn't matter. The number should give you, if you reach a sufficient number of iterations, the result should be always the same. Okay, should converge to the same distribution. Okay, so how do we make now 1,000 iterations of Monte Carlo? You have to select first the whole row, right, that you want to drag down. Then you go on the cross, double click, and now you have done all the iterations. Okay, all the 1,000 iterations. Okay? Yeah. Now we have to, now we have to look at the results and see, to create that nice distribution that we're hoping for. But before that, I want to use the opportunity to introduce this BBA module. Okay? Maybe some of you don't know. Yes? Any problem? No? Is going on track? Okay, so BBA is a programming module that allows me to make, like MATLAB. It allows you to make routines, to write functions, to make things in an automatic way. And to access that, you have to, now that you lower the security, you can go to Alt F11, okay? Alt F11, and you should get that screen at the same time. Yep. Okay, so you have to press at the same time Alt plus F11 to access and we will start first with something very simple. No, you're not getting it? No?
Just type Visual Basic on the help tab. The next
Because in some computers you have
top bar.
some computers in front of the function keys. Okay, that's something also that happens very often. You have the key, right? And there you have, for example, the brightness. And you have here, I don't know, the volume. F2. So by default, if you press on that, it's going to activate whatever is on the top. Okay, if you want to press here at the bottom, you have to use the key function. Okay? I think that's what's happening to you also. No?
Because on Macs,
It's different. How do you go with Mac?
you have to type on Visual Basic.
At the top.
Maybe it's better to disactivate the developer tab.
This work
Yeah, to activate. Yeah, for Windows it should work. For Mac, he's saying that you go to here. Is that what you suggest, Juan Manuel? Is it?
Yeah,
Yeah.
it worked for me. I don't know. Maybe to enable Mac.
There should be
Because we have different versions.
Do we have to get Visual Basic Editor or macros?
No, the editor. That.
Editor, right?
Mhm.
Maybe
And
Is it
another.
something macros, or is this
Yes. Yeah, just click here.
first one?
Yeah. Yes.
Okay.
To get without F11, you can use. You go to File Options. You go to. I think it's here Customize Ribbon, and the ribbon is what is shown all the different options you have in the tab at the top. Options, Customize Ribbon, and then you click on the Developer to show you the Developer tab. And after you have it, you will get a tab here called Developer, and you can click here on Visual Basic to come into this environment. Okay? So, all of you here? Not yet?
Do we select the sheet 1?
These misbehaved Mac users. So.
Do we go sheet 1 or it doesn't matter?
No, it should be module 1.
Module 1?
Do you know how to change the language within Visual Basic?
That you have to reinstall Office with another language. Mm.
It's a different language than the Excel sheet, which is for some reason it's in Spanish.
I don't know. No idea. He should have the same language, so. We can solve it later. So just if you can work with her in now for the time being, if you both of you have the same issue. Yeah. Okay. Okay.
We can write, but we don't have.
Okay, that's just not necessary. We already have the results. Okay, this is just to introduce you to VBA. So here, some of you might, look like that, empty. So you have to open exactly the sheet you have, which in our case is called Exercise 3 Monte Carlo. Okay, and here you have different things. You can. So what I recommend, you see here you have modules. Okay, and module is like a common repository for any sheet that you're working on. Now we have 2, but you might have 8. So you want to have like a common database or repository where you fetch things from. So that's what you call the module. And just like this random function is something that is built in Excel. Someone programmed that it will give you a random number between 0 and 1. But you yourself, you can program things that you need in Excel. Some random function, some function that is not there by default. Okay? So for that, you click here on module. And now you are located in the module. So we start typing. First we declare the function. For that we say function. Okay, space. And then you have to give the name of that function. Okay, random, I call it with the name rand. That's how I call this function. Okay, that's how it is called. So I can say, for example, I can say it will be called original oil in place, right? That's how I'm going to identify that function. And then I have to say open parentheses to say what that function depends on. What is the input to calculate that function? Okay, so if you remember, that will be BR, volume, rock volume, porosity, we can use maybe pore. Okay, then saturation, SO, BO, and what else do we need? The net to gross. Okay, NTG. Okay, I close parentheses. Those are the only input that that function needs, and when I click enter, it should automatically close it. Now I have to say what to do with that input. That can be very complicated. It can be a series of steps, can be logical things. You can have a small subroutine, you can have a root finding, you can have anything you want inside. Okay, in our case, it's going to be something very simple. I want to make the product of VR, porosity, saturation, and net to gross divided by BO. Okay, so for that I say the name of the function that I'm going to return, OOIP, will be equal to VR times the porosity times the saturation times the net to gross divided by BO. Okay, and that's it.
I need to leave a space between each.
No, you have to type just the asterisk to the star. And some things to note here: the name has to be the same. The return value, most of our functions will be just one value. Okay, we calculate one value inside and we return one value outside. The name of the function has to be the same as the name of the return value. And that's a typical source of problems. Okay, you don't get the number, it gives you fail something, so that's a typical error. And also the same name that you use for the variables, BR, should be the same inside. You should call it exactly with the same name, honoring capital letters, small letters, etc. Okay, so now let's use it. So now remember to save. Okay, now this will be available any place in the Excel sheet. Any place I go, any sheet I make, everything, it will be available by default. Okay, so remember to save. and then I go to yeah. So how do I use it? For example, let's make one here, n, another n. Okay, let's call it n BBA. Okay, again will be exactly the same number. And to call that function, I just say click insert function at the top. Then here it gives me well, the most recent. Okay, but I click here on the category and I go to user define functions that I have defined, okay, that I have created. So in our case, we go down to O. It was in O, right? O is before P. Okay, original oil in place. And I double click on that and it tells me in a visual way that's all the input I need. Okay, so you select the rock volume, the porosity, the saturation, the BO, and the net to gross.
So,
Yep.
can you repeat again about visiting the function?
In the function, here you click function, you click user define, and then you try to look for this OOIP that we created. It should be listed there. But you have to save, remember to save the Excel sheet.
There was a problem with Excel and it had to
Which function?
Okay, that's why you have to save always. Remember to save.
Just get down.
I don't have this one.
Which function is it?
Excel save changes to the file for application.
Okay.
Oh, because we don't have to save it. We have to save it here from.
Okay, so then I select the rock volume,
Save it.
the porosity, then I save the oil saturation, the oil formation volume factor, and the net to gross. Okay, and that should give me exactly the same value that the column to the left, and then I double click and that should give me exactly the same. Okay, so why you say is a very simple operation. You know why you decided to make this complicated function. The thing is that when first it's easy to debug. Okay, if this one becomes too long, too complicated, you get maybe difficult to see where you made a mistake. Okay, so to make the troubleshooting in this line is not so comfortable. If you make it here, you know, here you can much quicker see what, you know, might be the problem evaluating your function. The other thing is that if you made a mistake on that equation, right, and then you use it some other place in the sheet, 7 different places, and you made the same mistake, you will have to fix it. If you do it like that, you will have to fix it one by one. If you make it using a BBA function, you just have to fix it in the BBA function, and then everywhere else is fixed. Okay, so for these two things, easy to spot the errors and easiness to spot the error, and the second is that you can correct it only in one place and it will propagate through the whole sheet. Okay, so that's why I recommend to use a BBA function. Okay, now let's we have the results, right? And we want to make this probability diagram. Let's see if we have time, 5 minutes. Yeah, we can leave it maybe for next. You have time to, or you have to run to another class?
Yep.
Yeah. Okay, so let's leave it for next class. Now we have all the results. We have to use a function called frequency that comes built in with Excel, and it will count how many occurrences we have in this 1000 automatically, of 2.7, of 3, of 3.2, and so forth. We are going to give it, you know, the bins to count. Okay, the number of reserves or initial oil in place to count. And with that we can make our distribution, and we will see there, you know, how you usually use those results. Any question before we close? No? Okay, so I wish you a good rest of the week, and see you on Monday. Okay, I think we have on Monday another guest lecture. Hmm? Okay.